Greetings. I have been expecting you. I know what you're thinking. How does a polymer like amylopectin convert itself into energy using multiple glucose monomers while proceeding with the processes of amylotic hydrolysis? Okay, maybe that wasn't what you were thinking. Anyhow, welcome to the 8th installment of our series where we teach you all about disaccharides and polysaccharides. In this video, we'll be discussing all about, you guessed it, amylopectin. Now, let's lay out some ground rules, shall we? Cue in the learning outcomes.
In this lesson, you should be able to define amylopectin and explain its biological role in plants, identify its structure as a polysaccharide, elaborate on the functions of amylopectin in starch, and differentiate its difference from amylose.
Now, going back to earlier topics of the series, we have starches. Now, starches are able to store energy for plants, being its primary molecule for storage. It also has two components, amylose and amylopectin, but we'll be more focused on this little guy right here, amylopectin. As a component of starch, amylopectin is able to store energy by simply existing. It then be converted into energy when need be, and for context, amylopectin makes up for 80% of starches. I don't know about you, but 80% is kind of a big deal. And speaking of a lot, it's also made up of a lot of these little fellows right here. We call them glucose. Specifically, alpha glucose. As you can see here, they go down. And if they go up, they're called beta glucose. So, amylopectin structure goes like this. It connects one glucose with another using its first and its fourth carbon, essentially creating a linear chain. A linear chain that we call a linear alpha 1,4 linkage. That's what the cool kids say nowadays, but hey, it works. But that's not amylopectin, you say? Of course it's not, it's amylose. Amylose is a linear structure. As you can see here, there's only one chain. As comparing it with amylopectin, with those layers, those beautiful layers, if you get what I mean. Layers. Oh right, so every 20-30 glucose units, they go down. They connect with the linear chain from below, creating a branched alpha 1,4 and alpha 1,6 linkage. That's the structure for amylopectins. Heading to another difference it has with amylose, its solubility with water. Amylopectin is insoluble in dihydrogen monoxide. This is primarily thanks to its intermolecular forces that hold it together. As you can see here, this is mainly thanks to the alpha 1,6 bond it has as a branch structure. Well, now with that smooth transition, we're off to the functions of amylopectin. Now, what does our little branch alpha 1,4, alpha 1,6 polymer actually do in the greater grand scheme of things? Well, if you want a detailed explanation, there's none. It just stores glucose. In a nutshell, this happens because amylopectin is a component of starch. It is comprised of multiple glucose units that the plant doesn't really need yet. Think of it like, a can of beans. You only open it when you need it for sustenance. It goes the same for amylopectin and glucose. But when the plant needs a lot of glucose, it converts this amylopectin into energy via enzymatic hydrolysis. Now, as you can see here from this diagram, enzymatic hydrolysis breaks down this bad boy into more glucose units. That's enzymatic hydrolysis. That's how energy is produced through amylopectin.
Pop quiz, hotshot. We still need to make sure you can manage to do these stuff. First up, can you select the amylopectin among the following? Oh, yep, I knew you could do it. Now, which of the following images functions similarly to amylopectin? Oh, wow. It's almost like you could see right through the answer. Here's another. Which one of these describe the structure of amylopectins? Oh, no images this time. No way, you're doing fantastic. Here comes the last question. Every statement in the list is true. Except for one, of course. Can you figure out which one that is? Whoa, amazing. I guess you're ready. Now, go out there in the pursuit of knowledge, bud. We'll catch you next time in DNA's Learning Center. Quick, cueing on the outro. Hey, you! What are you still doing here? Go check out the next lesson all about glycogen. Or, if you probably missed out on it, you go check out amylose.